Yeah, it's a really good question. I'm going to answer it this way because I think what's the next after healthcare data, and then we put in implants in the right place to individuals. What's the next after that? Well, I'll keep using total knee again. If you go back to the total knee patient, what hurts a lot after surgery? Your incision. And your incision's pretty big because these implants are pretty big. So now with robotics, how can we make the incision half the size? How can we come up with an approach to cut the bone, maybe in a different way, almost like building a ship in a bottle? How can we do that? Maybe with a robot, maybe with orbital burrs or things that expand, or maybe laser cutting or water cut, jet cutting bone. Maybe now we could use technologies not just to say, hey, we cut the bone better, but if we could go an incision half the size, think about this. You'll have less pain postoperatively. You'll heal faster. You'll cost the healthcare system a lot less money for everything else, and you'll have a lower infection rate because you have a lesser incision that has to heal. If we could start looking at everything from total shoulder incisions, total hip incisions, back lumbar spine incisions, there's so many remarkable things that you can make a difference. I think now it's not about the implant shape itself. It's not about where it goes in the patient. It's how do you get the implant in the body that's the most minimally invasive with the less soft tissue trauma to reduce complications and pain to that patient. That's the next, it may take 5 and 10 years for us to figure that out. But honestly, that's a game changer.
In this podcast, I'm sharing my passion and curiosity for soft robotics, where we share inspiring stories about the work we do and how we can push the limit. I am Mara Dwiney, and this is Soft Robotics Podcast. Support for this show comes from Science Robotics Journal. I really find Science Robotics to be a great resource for reliable and tangible research where we can really push the limit of the science we do in robotics. Great way to stay up to date with the published article is checking out the released monthly issue. All the links will be included in each episode description. We will also happen to have a regular conversation on the most published science robotic articles, where also you can contribute with your question and thoughts about the research. Thanks Science Robotics for sponsoring Soft Robotics Podcast. Or how would you like to define yourself if someone listening to you for the first time? I would like to define
Well,
yourself.
so I'd like to consider myself an R&D person, research and development, even though I have different leadership positions, and innovation, healthcare. If I ever want to be remembered for something, it's taking innovation and moving innovation forward and taking technologies, creative designs, creative materials, and actually using creative materials in unbelievable ways to make healthcare better and to improve patients' lives.
Mm-hmm. So maybe before going to your role at Stryker at the company, maybe if you can give us just the main landscape about the challenges when it comes to robots with healthcare. Can you tell us what are the main challenges now when you combine robots with healthcare?
Yeah, it's very interesting. The challenges, especially globally, depending on where you want to look, whether the United States, Europe, we could go Japan, even China now in that market. You have regulatory challenges where you have different countries have different local laws which sort of dictate us one way or another. You also have different regulatory processes, how to get a product to market, and how fast can you get new innovation to market? Does it need clinical data? But I think the really exciting thing, I'm fortunate enough at Stryker to start a new division called Digital Robotics and Enabling Technologies, where we've moved hard tissue robotics into my group, navigation systems, help putting a trauma, sports medicine, help putting in a shoulder, a hip, a knee, spine implants. So really exciting technology in the operating room. But now I think one of the more exciting things is how do you utilize that and continue to improve it? How do you give a surgeon more information on that patient? And that's where digital healthcare comes into play. And the future of digital healthcare data and how a patient is preoperatively, expectations postoperatively, helping a surgeon decide what implant a person should get, where the implant should be. Should that person be in the hospital for 1 day or 3 or 4 days? Should that person go through 6 weeks of physical therapy or 8? What are the expectations of success with that patient? Now we have the capability to start collecting healthcare data on population health in amazing ways. And that, I think, is going to be the next level for Stryker to help improve outcomes.
So maybe if you can tell us the mission of a Stryker here, your vision, because you have been in different positions at the company, but if you can give us insight about the main problem or the challenge. You mentioned interesting parts here, but maybe you can elaborate more about the mission the company is doing here for healthcare here.
Yeah, so the mission of the company, Stryker's therapeutic. Many people should be familiar with Stryker if unfortunately you had to go to the hospital. So, good amount of beds, hospital beds, are Stryker beds. That gold stretcher you see on TV shows and back of ambulances, that's a Stryker stretcher. So there's many different areas of the business. So in the patient hospital room, there's Stryker products. In the operating room, there's Stryker products. In back of the ambulance, there's Stryker products. So if we just focus to answer your question, if we look at what goes on in the operating room, well, Stryker sells a lot of different implants. For example, someone breaks an ACL in their knee, that's sports medicine. Somebody breaks a bone, that's trauma. Someone has arthritis in their shoulder, that's total shoulder. Arthritis in their knee, that's a total knee. Foot and ankle problems, as we get older, we see more of those problems. Spine, scoliosis correction. Someone who has unbelievable spine needs a spine fusion. All of those implants get benefited from imaging, CT scans, x-rays before a case. What insights can we get off of CT on a patient? In other words, how's the bone quality of that patient? Maybe that'll help us select what implant. What's the expectation? What's the age of the patient? What's their bone density? That helps us. How complex is their fracture? That sort of gives us insights. Okay, that's one part of it. And then maybe preoperatively, you've seen probably great computer images of three-dimensional bones and how you could recreate bones from imaging and look at them on a computer screen. The surgeon can perform now a lot of the planning of the surgery, not in surgery, but prior to the surgery at home on their laptop. They're pulling in the image, CT scan, MR. They're pulling in virtual computer models of Stryker products and placing those virtual models on the bone in a place that helps repair. Here's where Stryker comes in. So Stryker helps with that software. But now we have a plan of the fixed bone. Let's use a total knee implant. Everybody knows someone who had a total knee implant. So you got big arthritis and pain, you get a total knee implant to help walk, right? Total joint. Now, where that implant needs to go relative to you as an example, well, your anatomy is very different than mine. Your joint line is in a different place. Your ligaments, bones, tendons, all are different. Now, though, we can get into personalized, individualized medicine. What implant is best for you? And where does that implant go specifically in you to recreate your joint line? And as you flex, as you get out of chairs, get out of cars, walk up and down stairs, where that implant goes, that's going to be data leading to technology to statistical significance. And then we're going to load that plan into Stryker equipment in the operating room, maybe a robot to help execute exactly where the cuts of the bone should be to execute that plan, or navigation systems that'll guide a surgeon through very small skin incisions exactly where that implant should go in that person. So that's really some of the challenges that we have now, but it's exciting because now we're to the point where we can collect data on outcomes. We have more imaging that's three-dimensional. We've elevated our equipment in the operating room to be able to accept plans. So it's nice where it's all coming together at the same time, and it's quite exciting.
That's very interesting. Maybe a quick question here about the reliability of accuracy. You mentioned very interesting examples here, but how you ensure the accuracy? Because we speak about here the surgeon or here versus technology. So how do you ensure the accuracy here or being reliable in the solution you offer for the patient here?
So we don't practice medicine. Surgeons practice medicine, but we supply the equipment. So let me give you an example. If you're flying, you're in Zurich right now. So if you want to come see me in New Jersey, you're going to fly to Newark Airport. So you're going to go from Zurich to Newark. and you're going to go maybe in a big Airbus, right? And that big Airbus, once it starts to go in the air, it's on automatic pilot. You feel comfortable with automatic pilot. The automatic pilot is taking the best conditions of wind, storms, and knows exactly where Newark Airport is in New Jersey and is finding the most optimal flight path to get there safe, accurate, and precise. That's exactly what we do at navigation and robotics. It's about not coming up with a new plan. It's about executing the plan with a precision that a tool, in this case a robot, can do to help execute the plan. So we have many, many different software engineers that do the development. We, as an example on the robot, let's keep using the total knee example. On the robot, we design the robot. We write the software and we build the robot just because of the concerns, because it's a very, very complicated piece of equipment. But once you have it right, you have it right. That's why not only do we have an awful lot of people who write software and build robots, we got a lot of people in quality assurance. And we have a lot of people in manufacturing engineering to assure the consistency of the product is always held at the best quality and the validation and verification to the specifications. And I can tell you right now, example on total knees, we have 1,500 robots in hospitals around the world. And get this, we're doing 28,000 total hips and total knees with a robot every single month. 28,000. So we've taken technology and a good use of technology, made it consistent, made it safe, made it accurate, made it precise. But patients are getting the benefit out of this where they're walking better sooner. They have less pain sooner. They're returning to flexion sooner. They have less physical therapy sooner, and they return to work sooner. All good things for patient satisfaction. So technology for a good use, assisting the surgery, but it's all about that accuracy and precision you did and targeting and executing to a plan.
That's great. Maybe I want to touch again about you mentioned the fabrication and manufacturing and software, and I think there's many aspects here from designing the robot that could be safe and also convenient to deal with the patient, and also the software and how to be more intuitive for the surgeon and easy to deal with. Can you just about the process, the combination of the manufacturing and software, whether that may be the most challenging part when it comes to having a product for hospitals here, like medical robots here?
Yeah, I think it's not really a challenge because you're developing new things, but so it does create, if you will, a new way of thinking. And you may have heard the term that's come into play a lot, especially in medtech, called customer-centric design. And where customer-centric design, in this case, even though the patient's the recipient of the implant, it really is to help the surgeon facilitate the procedure itself, that surgeon. And that surgeon, when that surgeon gets a plan, well, what's the surgeon first going to look at? What are the things on a three-dimensional image of bone the surgeon's looking at? What anatomic landmarks? Okay, well, now that's partnership because software engineers need to say, okay, we need to be able to auto figure out exactly where those landmarks are to help. Because if it takes too long, if it's going to take 3 days to plan a case, no one's going to use it. So you have to have something that's relatively straightforward, easy software to understand. Just like if you have an iPhone, you the apps are meant to be user experience plus, right? Not a long time to figure it out. If you had to spend 5 minutes to figure out how to use an app, you would probably never use that app again. So there's a value proposition, right, where you get clinical benefit, but it can't be too complex or problematic. So understanding all the insights that make a total knee work better, where it is, what kind of patient, what kind of positioning, what kind of post-operative care, what type of care in the hospital, care at home, and understanding all of that. That's a partnership. That's a collaboration on innovation, and that's with the physicians and with the R&D folks. And then you work through, but you're treading new water, right? You're going in a new direction, which has never had before. So unbelievably awesome that you get to sit and work with people on this. But it takes a while to get it right. So you got to get through some of the frustration. You got to stay positive. And it's software. And sometimes, people spend a lot of time on software and maybe it didn't work out as right. And you got to keep going, going, going. I think the positive mindset, but I think now the collaboration between hospitals, physicians, patients, an industry. That's really the next level. Nobody ever partnered before. If you're thinking of yourself as a patient, when's the last time you partnered with the hospital on data? You probably didn't. Maybe the physician, or maybe you didn't trust anybody. When's the last time government, especially some of the socialized medicine countries, they never shared any data before? Now everybody realizes working together is a huge benefit to take outcomes to the next level. We're excited about doing that. Challenging, but exciting.
Great. Maybe I want to touch again about this point because you mentioned the innovation and taking a new way of design and thinking. Maybe realistic speaking, when you try to have this product and you also to design to bring something innovative and new, how you merge the two? Because it seems sometimes it's risky maybe to do new design or solutions. Maybe it doesn't work, as you mentioned. So how you find the middle ground that something could be a product and also still innovative? Do you think there's mismatch here between two, or you don't think so?
No, there's certain aspects of surgical procedures that are a little riskier, right? Total hips and total knees, we do in the hundreds of thousands of them, so very little risk. The risk on a total knee procedure would be that our equipment fails. That we can handle in the factory and in design, pressure test it, look for vulnerabilities, and that we can go well. We also have a business for neurovascular, where someone had a stroke, to help resolve the blood clot. We have coils that have to go through the arteries to get to the brain. Now, in that case, that's a lot of different risks. If the coil's not put in the right place, if the coil's not designed right, if the coil breaks. So there's different things associated with that. So in that, you do a risk analysis and a risk table to assess each one of the risks, firstly, in the device failure modes, then the surgical procedure and just inherent risks of the surgical procedure. And then we look at the surgical flow. Exactly how are we getting the Stryker implant to where the patient needs it? What anatomy are we going through? What risks are associated with that procedure? And then often we will then look at different opportunities and different approaches to get an implant in someone, and then to understand, okay, which one of those approaches is the least risk, and try to resolve all risk if possible. So surgical workflow, maybe you're familiar with that term, workflow, surgical workflow, surgical approach, indication application, design, and failure mode analysis. All those things make this very complex, but we do all those for every single product we do in every single application.
Awesome. So maybe before going to the material design here about the implant, maybe the robots here, maybe I want to talk about the redundancy. You mentioned the failure, and in such a situation like that, how you ensure redundancy in the operation here for the using the technology of robot redundancy here.
So let's take a total knee just because everybody knows it. Maybe I'll just keep using the total knee example. So if you think about a total knee example, you never want the metal to break, like ever. And it's a metal on plastic bearing. So the metal of the femur has a plastic part of it on the tibia, and that articulates, right? That allows motion. We'd like these implants to last 30, 40, 50 years in someone. Now, some people are more active than others. Some people are more obese and put more weight on others. Some people will live longer, more active lives. So you have to come up with a scenario. We will actually, the very first thing we'll do is we'll fatigue test these implants. And we'll fatigue test them 20 million, 30 million, sometimes more cycles to actually replicate years and years and years of walking. And then we'll assume an average body weight for that implant and then give it a factor of safety by 4 to 5. So upload the factor of safety to show it's more load, maybe 4 or 5 times than a normal human would on that joint, and do it for 20, 30 million times and look for no failures and no breakages. If you keep doing that repeatedly, you learn and you build up this competency over a period of time where you know where high stress points are, where maybe you will get a crack in an implant. Or through all the years of total knee implants going in people since the 1950s, 1960s, you can see where people load implants, you know where people break implants in the past. So you learn and you build up the archive. Healthcare and people who need an implant, total knee again, as an example, really fortunate to be living today. It benefits on history, multi-generations of design improvements, better materials than ever before, better quality materials, stronger materials, lighter materials, more biocompatible materials, and we get the benefit of design aided with computers that actually help us do stress analysis, and we could do creativity on geometries. It really is a fortunate convergence of all these things that make these procedures very, very safe procedures.
That's really excellent. Maybe I want to go for this point about the material since you mentioned implant here. Maybe we can touch again about the material since you mentioned many features here about the material for the implant and you ensure that for yeah, we are different as human beings, different condition, but how you see the design if you come up with new design for the implant for certain features and also the material. Do you think there's something still maybe interesting in the design and how we can push the limit of the implant, or it's already at the top?
No, in fact, so as I said, I'm an engineer, and engineers are limited. Engineers are limited in design capabilities by strength of material. Engineers are limited in design capabilities by geometry. We do have a human being that we have to appreciate and respect their bony anatomy and not make something that's 3 feet or 3 meters wide, right? I think in this case, though, to your question, a lot of good materials. The very first fundamental, it has to be biocompatible. Your body cannot reject the metal or the plastic. Cannot. So we're in good. We know titaniums, cobalt chrome, ultra high molecular weight polyethylene polymers, and different other materials. So we have a good track record of those materials. By the way, all those materials are corrosive resistant. Then, but let's talk about the exciting part now to show you that we're not done. And that's with the advent of additive manufacturing, 3D printing, that we can now take titanium alloy powder, which is totally biocompatible, and now with lasers, we can build up a part geometry that only 3D printing could. Before, we were limited by conventional manufacturing processes, such as drilling, mill, lathes, turning, all those that limited a shape profile on a certain type of material, which was machinable. Now, I could come up with virtually any shape that I wanted. I am completely unencumbered as an engineer. Now I could look at geometries that are more flexible, maybe that are thinner and more bone conserving in places, maybe something that matches the patient's anatomy better. So 3D printing not only allows us different geometries and to do different shapes, but also we could put on, remember, implants one side, they're moving against one another. The other side of it, they're against bone. So we want bone to fix to these implants. Now we could look at different porous metal cellular structures for biologic fixation that may be able to last longer in a human. So super exciting things. And this is only over the last 5 years. So we have a long way to go to unlock all the potential of additive manufacturing.
I'm glad you mentioned this point. This is really very important point. And I'm curious to ask you in that case because you mentioned additive manufacturing and 3D printing. And we speak about here multi-materials because I don't know in the implant you use different materials you can operate, but how you ensure that every piece is the same because we have two approaches here, traditional way in printing, additive manufacturing. How you ensure that the same thing is reproduced? There's slight changes. I don't know from your here the experience with our company here. Do you have a challenge in this part?
Yeah, it's challenges to validate and verify something because sometimes maybe if it's inconsistent, we did a bad design because it can't be manufactured, right? In the old days, that used to be more the case. Additive manufacturing is a little bit different. So what we do, let's go through a total implant, total knee implant again. Let's say I'm going to take titanium and I'm going to machine titanium. Well, we get the raw material, titanium, in a block. That block we're going to verify the material properties of the block. So we're going to know it's all mechanical properties, it's chemistry, all of that we're going to know. So we're starting off with the material before we even make the implant that we know is good. That's so you resolve a lot of unknowns from a weaker material or unfavorable material. Then as we machine the implant, we machine it, and then every single implant is inspected for its geometry and dimension. Every single implant. And in many cases, the implants are checked to microns of the thickness with a laser. and every single implant goes through that form of inspection and through validation of the very first production run, where we may sample hundreds and hundreds of every single part. We have a pretty good consistency that we have a manufacturing process that's robust and reproducible. But then there's more though, because that implant has to go in a package and has to be sterilized. So now it's not just the shape and the material, it's did we do sterilization? So we also have to validate all the sterile packaging. So we put it in double, what's called blisters, plastic, you peel off and you got another one you peel off to maintain sterility. We design those as well. And then that goes through a validation, including drop-in vibration, delivery person. You don't know if they drop the box on the loading dock or heat. Maybe you're getting a Zurich hot summer, of 35 degrees and more. And is the package going to be good? Is it going to be good when it's freezing in the back of a truck outside? And then did it maintain sterility? When we sterilize these parts, so we're sure no air or bacteria can grow on the parts. We validate all those and we check the representative of those on every single production lot. So we put more time, because we're in the medical industry, into the inspection and post-processing. And in many cases, the cost of quality assurance and packaging exceeds the cost of goods of the actual implant.
Awesome. Maybe I'm curious to ask you, in your experience, your rich experience here, there's something, maybe lesson you learned, something, in this experience to do with hospital and at a product here, something, just a failure in design or something. It was quite interesting to you to change the way of thinking here in design. Do you have something from the past you can recall? Yeah.
Well, the good news is I've been around for a long time because I haven't had any failures of design. So that's a good thing. But to answer your question, though, I will tell you, one of the things I think I see people being very conservative. So in this medical device, we don't take risks. Sometimes we don't make incremental enough improvements in something that we could. And these are the quality of life for patients. Engineers, right? You could put more geometry, which may make someone's knee bend further back, which means they can get off a floor unaided when they stand up. That's a really huge difference than a conservative approach of moving. And were there some designs over the years, did I challenge myself enough? Did I really use all the technology as enough? Did I then really take into account creative thinking and not just think about it as a product or a project, but think about it truly as innovative? And did I take into account all the innovation potential, not just using technologies, but technologies is nothing without people. And it's people's creativity and that spark that use these technologies in the best way. Like 3D printing by itself is nothing. It's absolutely nothing. It's the creative designs that could come out of it, and that's coming from the human being who's engineering it. So I think over, the years I've learned to push more and more, which is probably why I got this great job at Stryker now. But when we have new interns coming in to Stryker, when I go speak at universities around the world, I actually bring up this point all the time. There's really nothing that's limiting us half the time other than our own creativities, our own spark for imagination. It's not just about getting a project done. It's about getting a project done right.
That's a good words. Yeah. Maybe I want to ask you again about the choosing problem, because if I ask you, when we speak about robots here or technology to for something in medical, like surgical, you mentioned the knee, for example, but if there's something still challenging, do you think, when you bring the two together, the robots and or the technological here with the medical part, is this something, challenging problem? You still think this is really hard to be achieved at the moment? You can't touch it.
Yeah, it's a really good question. I'm going to answer it this way because I think what's the next after healthcare data, and then we put in implants in the right place to individuals. What's the next after that? Well, I'll keep using total knee again. If you go back to the total knee patient, what hurts a lot after surgery? Your incision. And your incision's pretty big because these implants are pretty big. So now with robotics, how can we make the incision half the size? How can we come up with an approach to cut the bone, maybe in a different way, almost like building a ship in a bottle? How can we do that? Maybe with a robot, maybe with orbital burrs or things that expand, or maybe laser cutting or jet cutting bone. Maybe now we could use technologies not just to say, hey, we cut the bone better, but if we could go an incision half the size, think about this. You'll have less pain postoperatively. You'll heal faster. You'll cost the healthcare system a lot less money for everything else, and you'll have a lower infection rate because you have a lesser incision that has to heal. If we could start looking at everything from total shoulder incisions, total hip incisions, back lumbar spine incisions, there's so many remarkable things that you can make a difference. I think now it's not about the implant shape itself. It's not about where it goes in the patient. It's how do you get the implant in the body that's the most minimally invasive with the less soft tissue trauma to reduce complications and pain to that patient. That's the next, it may take 5 and 10 years for us to figure that out. But honestly, that's a game changer. That's a good use of technology. I think we have the technologies there. Figuring out how to do it's not so easy.
That's a great. Can you maybe share some point here? I know it's not easy, but can you just brainstorm a little few points? What could be lead to solving this problem that you mentioned? Just speculation about what could, yeah, about what could be solution, yeah, for this problem. Yeah.
So I think in medtech, I think one of the solutions may be already there. I think it's now time because technology has evolved not just in the healthcare industry, automobile industry, aerospace industry, manufacturing industry. If you look at all those technologies, I think we may be in a place right now where the answers may be there already. And now it's time for us to branch out to other industries and see how other industries might have a technology or a cutting tool or a cutting path or a way to do things than a less profiled piece of equipment. So I think one is we as good healthcare engineers need to get out and look at the rest of the world. I think number two, I think now, I think it's that workflow I talked to you about surgeons. I think surgeons aren't going to be able to, if they want to do incision half size, they're probably going to have to learn a little bit differently and maybe approach the joint in a different direction. Maybe not from the front, maybe from the side of your leg. Totally different workflow. We talked about customer centric design before. This is a changing way to way people are used to doing things. And once you change the norm, it's quite disruptive. So we have a different surgical approach technique. We have a different way of learning in medical education. We have different technologies to help approach through smaller incisions. And then we have to marry all this together because each by itself is nothing. It's how it comes together. And that's going to make a lot of stakeholders have to work together. That's going to have a big desire. And then we got to show it's safe. We got to show it's clinically effective and it's good for the patient. And we have to make sure we get rid of all the risks. If we could do that, we will be moving the needle so much on what's to do, but that's what the future needs to hold. People working together, customer-centric design, willingness to change the way we've done things in the past, instead of just generational changes, make a disruptive change that could have a huge benefit, and let's rethink the way we do everything today.
That's really good point. Maybe quick question here about customer-centered design. Maybe generally speaking, how do you see the generic maybe design here? If we speak with different patient, can you see the difference here if we speak about generic design that can adapt, or if you can elaborate more?
So instead of an engineer coming up with something, it's called waterfall effect, right? Instead of an engineer coming up with a design, then seeing if it could be made, and then see if it could be used, and then seeing how it's used. That's very sequential, if you will. That's not really taking a customer into account. Going backwards a little bit, like what is the expectation of the patient? What actually makes the patient happy? What's the patient's problems? Okay, that's the customer. So now you're going back for what the problems are and you're working backwards. But you're involving the surgeon because the surgeon is a key part of where the implant goes, how to do the surgery, how to plan, and what are the principles and parameters that that surgeon is looking for in that patient with that specific problem. Then as engineers, what do we have available to us in our tool chest that we can throw towards this? And then what could we bring forward from our learnings of the past? That's all staying around what's best for the patient. How do you improve outcomes? How do you make the person walk better? As I said, get out of a car better, walk up and down stairs better. And then what are all the parameters to that? An engineer sitting alone can't answer that. A surgeon sitting alone can't answer that because they don't understand the technology or have the tools, and we need to program and design it. That's where I talked about. It's that partnership of multi different stakeholders that brings customer centric design together versus me sitting in my office here in New Jersey and then sending out parts and say, hey, does everyone like them? So we're going to do this, and we're going to bring in more points, bring in more people to have a voice, and then I think we'll be able to rally around that and then look at what technologies or what new innovation we need to help solve problems to make a real remarkable change.
That's great. Since it comes then, I have a few questions for you. You mentioned at the beginning that what drives you, of course, finding innovative solution, using creativity here. But when you look for the competition, I don't know, how do you view competition when it comes to providing the product or solution? I'm just curious about when you see competition here and you want to be standing out with your product here. How do you see that?
So there's an expectation, you could take car manufacturers. There's an expectation that one car company always wants to be that car company, and some excel, right? You can say the same thing about airplanes, and there's different airplane manufacturers, different airlines, right? I think in all the market segments Stryker plays, and Stryker wants to be at the top of the house, top of the game, best car, best airplane, and we strive for that. So we go for not say a value product that may not give you as much clinical benefit. We try to maximize the clinical benefit as possible. I think we do that better than any other company. And relative to the robotic market that's out there now, I'd say in hard tissue robotics, not only is Stryker ahead on design and innovation, but we probably, um, I think, out of our procedures, total procedures in the world, if you take everyone else all together, competition, and then double it, we still sell more, and we still have more people buying our robots, which that's technology that's good for the user. People see clinical benefit. People see that that's a value. That's something that's a platform that's going to last a long time. It's easy to use. The software is good. So everything that I mentioned in customer-centric design, innovation, ease of use, and getting true, not just marketed, true clinical benefit that surgeons see in their patients. We strive to do that in all the enabling tech, all the robotics, and when we do our clinical insights off digital healthcare data, we're going to be the exact same way.
Great, great. Maybe you have been many years now on that domain, but I mean, I'm curious to talk about the design iteration. Every time you say all the design work, that's great, but I'm just curious, every time you design new design, is there something you're afraid, just some timing? Yeah, I don't know if you have fears about the design, even if that data is correct, but still you get that aspect until you see real application. Yeah, here.
I think you look at the generational change. I'd look at it differently. I don't think it's fear because we wouldn't put anything out that we fear. That would be irresponsible, but also regulatory and everything else. I I'd answer it a little different ways. I would say, let's go through total knee. In the 1970s, if someone got an implant in the 1970s, seems so long ago, right? 50 years ago. You know what the expectation of that total knee implant was? That somebody could get out of bed pain free, walk to the kitchen table, and go back to bed. In the 1980s, what was the expectation? Patients wanted more. They wanted to be able to walk, and they wanted to be able to walk in a supermarket unaided and pain free, and then go back home. In the 1990s, you know what? People want to play tennis now. People want to play golf. They want to be more active lifestyle, even though they have limitations. In the 2000s, total knee, go up and down stairs like you don't know that you have a total knee, and be able to chase your grandkid if you're a grandparent and not have any pain. Expectations in the last 10 years is that you can get off a floor unaided and stand up yourself. Isn't that a difference in patients' expectations of a total joint over the last 50 years? So now people want, you say going forward, people want a joint that lasts forever. People want a joint where they could jog. People want a joint that they don't even know they have a joint, but also short term, they probably prefer a smaller incision with less pain from surgery. So now is an interesting, the pain and the outpatient surgery is becoming more dominant, where that wouldn't even been considered. In the 1980s, you had just been happy getting a total joint, regardless of how much pain, because you'd heal, because you were in so much pain before and you just wanted to be able to stand up again. Now, people want to play tennis, go walk up and downstairs, and never have a problem with their implants. That's the challenges we get, and we accept those challenges as we further evolve total joints.
Hmm. That's really a good analogy here. Maybe a quick question about if there's damage happening in the implant. You mentioned you make cycles for like 20 million and to make sure it's lifetime. But if there's damage happening here, how do you see about the healing of the implant? Do you ever thought about that, or does it make sense to you? This kind of part damage.
Well, no, I spent a lot of work on there for 30 years on bone growing into implants. We have a good understanding of it. Computer modeling hasn't replicated the human brain, so I still have a job for a long time. But the way bone reacts to load in the body, the way bone reacts to metal, the way bone reacts to geometry, all those kind of things make a big play and a big difference. So we design implants with structures, materials, and surfaces, understanding the phenomena of bone loading, the phenomena of bone growth, the phenomena of the aging condition of the implant, because decades later, we want that implant stable in that person and pain free. So we take into account all of that. So the biology is very important. So when we're doing implants, I have biomedical engineers, mechanical engineers. If we do robotics, we're still taking into account what bone is best to grow. So even the robot people, when we are assessing where bone cuts should be, we're taking into account implant stability as well as long-term biologic ingrowth. So that's a key part of what we do. We are putting something that we want to become part of the body for decades.
Great. So maybe if you could lift, what maybe your vision or aspiration when it comes to Stryker here? I mean, for the future, what do you envision?
Yeah, we'll keep evolving. Great question. We'll keep evolving implants with 3D printing, so that's exciting, right? Maybe less bone removal, maybe smaller incisions. With enabling technology, whether robotics, navigation systems, it'll help the surgeon put the implant in with accuracy and precision off a three-dimensional plan that they couldn't do with conventional instruments. So we have great implants that are additive manufactured now, new geometries. We have new ways to prepare the bone with the surgeon, and that's all with robotics and things like that. But this digital healthcare data, using statistical significance and population masses to understand medicine and what's best for an individual patient, I think that's super exciting. To be able to, I'll just give you a quick example, but to say I have a 64-year-old female, um, a BMI of 39, so really obese, a bone density osteoporotic patient, and they have diabetes. What implant's best for them? Where should it go? Are they safe to go out of the hospital in one day, or should they stay in 5? How long should they be on pharmaceuticals to make sure they don't have an infection? How long should they have physical therapy? When should they go back to work? Can they walk up and down stairs right ever? Manage expectations. All these kind of things, I think we as a med tech medical device manufacturer have a responsibility to do because the data is now available to us. It's just no one ever looked at it before. That's the future. Being able to further improve by using data that we never had or were incapable of using before. Now the future is a bright one. This journey is still not over yet on improving outcomes and patient satisfaction. And we as Stryker, we want to be a key part of that.
Great. Maybe it's a question left here. The first thing about what maybe the customers. You mentioned hospitals here, but I'm curious, do you have also research development? I mean, cooperating with universities? Well, maybe the potential customers you can share here.
I think partnering with university, I'm a big fan of. And in fact, I don't think industry does it enough. Right now, industry learns a process, scalable process, but technology is changing fast. And that technology is usually adopted first in the university. Usually there's brilliant faculty in university, really smart students that are working on that. They know more about that equipment and the equipment capabilities than anyone in the company does at this early stage in that technology. So feasibility testing, why should a company do it? Why not have a collaborative research program with a university? So right now, I do Stryker, and I'm president of this digital robotics enabling tech, but I also chair the board of trustees of the New Jersey Institute of Technology in Newark, New Jersey. It's a relatively large STEM polytech. A lot of engineers graduate. It's about 12,000 students total. And the amount of research and collaboration research with industry is changing. So I'm a big supporter from the university, pushing the university to collaborate more because I think this will help innovate. It'll help innovate faster. It'll bring technology into the markets. It's good for workforce creation. It's good for the industry as a whole to keep evolving faster. But the faculty and the students in university right now, and I can speak for New Jersey Institute of Technology, but other universities that we deal with as Stryker as well, people are really smart. Even if I hired a person, that person is going to take a long time to even get close to be as smart as that faculty member. And then the students under that faculty member, the PhDs or the postdocs, they're absolutely brilliant. That's talent that could be given a project as an extension of the R&D inside the company and can help facilitate not only to get a better end product and a better result, but get it faster and probably more cost-effective means. So I'm always amazed that industry doesn't partner more, partially because I think it's too complex. People don't know how to do it. The playbook on how industry academia partnership happens is a little bit confusing, but there's so much possibility. It is underutilized everywhere in the world.
That's great. Maybe I want to ask you what makes you fulfilled, and maybe if there's advice in this journey was given to you and stick to your mind. What makes you fulfilled, and if there's advice, it still stick to your mind. You want to like share
Which job? My Stryker job or my NJIT job?
all of them,
Well,
both. Yeah,
I'll
you
speak
can.
for twofold, by the way. So I'll talk from the university side. So bringing the university forward, coming out of the pandemic, a lot of universities are strong. A lot of universities are seeing the potential for research. Industry, don't be afraid to reach out. You will find more receptive university people that want to partner with you than in the years past. The world is changing. Universities need industry, but I think industry needs university. So often I hear people just don't want to be bothered or don't want to try, and you'll feel much better. So I got to speak my mind on that. As far as healthcare goes, I think there's a lot of innovation around the world. We shouldn't accept status quo. We should show bold leadership that's innovative. People should be able to speak their mind. People in other industries that have technology that maybe help Stryker or MedTech should bring those technologies forward. People that are looking to get into MedTech for jobs and careers and things like that. It is really a growing industry. The population's getting larger. Problems are always occurring, and anything that we think we solved, we could still get better at. And I think more people more focused on this. I truly believe collaboration going forward. Industry sitting by itself with blinders on, thinking they could do everything internal. Those days are over with. They're just gone. The way to really innovate, to move the needle forward, and to really make progress in the healthcare sector is for industry to partner with government, industry to partner with hospitals, industry to partner with academia. And I think, my goal in life is that I get to see government, academia, hospitals, and industry all working together because that would be unbelievably mind boggling with all the viewpoints and opinions around the room, not to mention all the data you'd be able to get. And I think as we evolve the culture of partnership and collaboration, I'd like to see that go faster. I'd like to see that accelerate. There's very little downside to it. I know it's not what people normally do, but the upside potential is just too big to waste.
That's yeah, I share the vision. That's really powerful message here. I don't know if you have any final words like to say for people listening. Any final words like to say here? Final words.
Final words, final words. Well, thanks for the opportunity to talk about this stuff. I think the med tech industry is a great example of using technology with people to innovate, to solve real problems. All our real problems aren't solved. I think there's a lot more to do. And if anyone is thinking of the healthcare industry, med tech industry, or whatnot, it's super exciting. It's a great, rewarding career for me. I've been doing the same thing for 35 years, and my story's not over yet either. There's still more to do, but the idea to take away technology and solve real people's problems and improve patients' quality of lives, that's exciting to me, and I'm going to keep going at it.